Drinking water. Where does this water come from? Most people in the U.S. get their drinking water from a lake, reservoir, or underground rock layer. Drinking water comes from either a private or public supply. Most larger communities maintain public water supplies. These communities collect, treat, and distribute water to residents. To other less populated places, wells will supply water for each individual family. What are some diseases that can occur from untreated drinking water? Bacterial infections include typhoid, cholera, paratyphoid fever, and bacillary dysentery. Viral infections are jaundice, poliomyelitis, and protozoal infection. Water also has lead, which in high amounts may be infectious to the body to affect the central nervous system. Petrochemicals in water may also cause cancer at low exposure levels. Chlorinated solvents in water may lead to disorders and cancer. Arsenic poisoning in water can cause liver and nervous system damage. Nitrates in water are fatal because they restrict the amount of oxygen that reaches the brain. Other exposure to polluted water may cause diarrhea, skin irritation, respiratory problems, and other diseases. Of course, this depends on the pollutant and the body of the person. What are the most common chemicals found in water? Chemicals found in water include fluoride, arsenic, lead, petrochemicals, the recreational use of water or sewage, other heavy materials, and chlorinated solvents. It is good that fluoride is in water because it helps with protection of the teeth, the prevention of weakening of the bones. Arsenic comes from overpowering aquifers or from fertilizers. Arsenic is a metallic element that forms many deadly compounds. Lead is in water because of pipes, fittings, and solder. Petrochemicals are from storage tanks. Chlorinated solvents are metal and plastic effluents, fabric cleaning, and aircraft manufacturing that are discharged. In Hawaii, how do they treat our drinking water? In Hawaii, we have a lot of precipitation. This precipitation will pass through very pristine rainforests and then proceed to filter through thousands of feet of lava to create aquifers. Lava rocks to create aquifers, which are our source of natural water. This process includes pre-filtration to remove solid particles, carbon filtration to remove chlorine and other contaminants present, sodium chloride, which removes calcium and magnesium if present, ultraviolet light, first step to kill bacteria, reverse osmosis purifier to remove dissolved solids, second ultraviolet light, second step in killing bacteria and viruses if present, ozone injection, third step in killing bacteria and viruses, and finally, micron polishing filter. Final filtering process prior to bottling to remove any particles that may have come from processing equipment. Which is better, harvesting rainwater or aquifers? Rainwater pros. Helps solve droughts, desertification, erosion from runoff, over-reliance on depleted aquifers, cost of new irrigation diversion, and water treatment, and helps to solve for the cost of water treatment facilities. Also, rainwater is easy to purify. Rainwater cons. Rainwater is contaminated by algae, air pollution, bird excrement, leaves, sand, and dust. Cost is high for the required tanks and accoutrements to harvest rainwater. Aquifers. Pros. Water has already been filtered. Water can be removed as needed year-round. Water cannot be lost by evaporation. This system is less expensive than surface water systems. Aquifer cons. Water table lowering, depletion, subsidence, water intrusion, chemical contamination in groundwater, reduced stream flow, surface area contamination can get into the groundwater. What chemicals are used in the purification process? Coagulants are used to cause impurities in water to clump together. Ferric sulfate, polymers, and other chemical additives may be used to form organic and non-organic impurities to adhere and sink to the bottom of holding tanks or basins. To create safe drinking water, the key is to kill harmful waterborne pathogens. Usually chlorine is added to raw water just to cleanse it. Another way of purification is the diffusion of ozone O3 into the water to oxidize waterborne pathogens. Carbon dioxide or calcium carbonate slurry may be added to water to lower our pH level. Why do wetlands matter to our drinking water? Wetlands help to protect and replenish surface and underground drinking water sources. Studies have concluded that the thousands of small wetlands that dot the U.S. Great Plains play a significant role in the charge of the Ogallala Aquifer. This is one of the nation's largest aquifers used to irrigate the agricultural plain and provide drinking water to the Great Plains. This is my works cited. Thank you.